Hello everyone, today I'll be doing ANSYS tutorial for you. So before starting our tutorial, let me introduce the model that we're going to be analyzing today. So this simple model consists of a pin and circular block with a hole. So the surface of the cylindrical surface of the pin and the hole corresponds to the ISO standard H7P6. So today we'll be analyzing two cases where uh, where the hole has the smallest dimensions while pin has the largest, and vice versa. So we'll be analyzing this interference, the interference between hole and pin. So let's go to the ANSYS. So in ANSYS, we select static structural for this analysis, and let me note that today we'll be doing simulations for different materials. So we'll be analyzing pin and hole made of steel, aluminum, and plastic. So before starting our simulations, we go to the engineering data and select the materials that we are needed. So as you can see from here, as default, we have already steel. So let me add aluminum and plastic. So we select here we select aluminum alloy, and then we select polyethylene here, and we close engineering data. So the next step is to transport our geometry. So I already saved our initial model in a step format. So in order to import it, we go to the import geometry. We click browse, and here is my model. So first we'll be analyzing maximum interference case, and then we open our model. So now we have our model ready. So it's you can see here it's already imported. So on the left hand side we see geometry, coordinate system, connections, and so on, the list of things. So we go from top to the bottom. In geometry we see our geometries. So we see our pin, we see our block with a hole. So in order to change, so by default we see here that it's made of its material is structural steel. So if we would like to change the material, we can select or aluminum alloy, or we can select polyethylene. But for the first case we select uh, structural steel. So on connection tab, we see here our contacts. So our model has only one contact between the pin and the hole, and here we have different contact types. So for this contact, we give frictional behavior, and then we need to specify our frictional coefficient. So according to the engineeringtoolbox.com website, the friction coefficient between two plates of steel in dry condition is 0.5. So we are done with our contacts. Then we go to the mesh. So mesh is one of the defining things in finite element analysis, since its quality defines the quality of our entire analysis. So first, I would like to change the method. So we select all bodies, apply, and I would like to select tetrahedrons. Why I selected tetrahedrons? Because tetrahedrons are easy to simulate. So the models made of tetrahedrons are easier to run. So then we can add sizing, we select both bodies and add body sizing, let's say 0.1 meters. Also, let's add some phase sizing in the interference with 0.05, and let's hide it, and let's select another sizing for the whole surface, and it's also 0.05. So, and generate mesh. So now we have our mesh ready. Then we go to the boundary conditions. So before starting boundary conditions, we select here on the analysis settings, we put large deflection on, since if we select large deflection in on position, it makes our simulations easier to run, and we less likely encounter any errors or warnings. So then let's start inserting our boundary conditions. First, let's introduce fixed support to the block, to the cylindrical block, and let's put frictionless support on both ends of our pin. This frictionless supports on both ends of our pin prevents our pin to move in axial direction, and also we have our block fixed. Then let's run our simulations here. So let me note that we are analyzing maximum interference case. So let's move. In order to save time in this tutorial, I already made several simulations with different cases, with different materials. Let me go to this to the results. So here we see our model, our results. So after doing all simulations, we see the stress distributions. So we see that maximum stress is around 230 megapascals, and we can see stress distribution inside of this along the pin, and also we can see stress distribution, for example, on the body of this block. Also we can see stress distribution along the hole. So for this steel, for the model made of steel, in the maximum interference case, the maximum stress was around 230 megapascals. Then let's have a look at the minimum interference case with the same material. For this case, we only have 5.6 megapascals. So we see that there is a big difference. So let's have a look on another simulations. So let's have a look at the aluminum, at the case with aluminum. So we have same boundary conditions, we have same contact parameters, and here, for example, in case of maximum interference, for the aluminum model we have 82 megapascals, while so for minimum interference case, so for the minimum interference case with aluminum we have only 2 megapascals, And these results comparing with the steel case, with the case with steel as material, it's much lower. For the case with plastic, in the maximum interference case, we have a maximum stress of 1.3 megapascals, while for the minimum interference case with plastic, we have the maximum stress of 30. For this case, we have 0.03 megapascal, which is much lower comparing with previous cases with steel and aluminum.